Hello, everyone, and thank you for joining today's webinar. Audio quality during live webinars isn't the best, but they do offer the opportunity to ask questions. So today we're going to take more of a hybrid approach. We're going to broadcast our pre-recorded webinar with optimized sound and our speakers Oleg and Uma, who are here with us. Hello.
Hello.
They will be completely focused on answering your questions in the chat. We will have a live Q&A session following the webinar as well. This slightly different approach will hopefully provide a better webinar experience for you all. All right, we'll go ahead and get started.
Hi, everyone, and welcome to today's webinar. I'm Michaela Williams, and we'll be discussing Kubernetes chaos engineering with MayaData and Kublr. Today's presenters are Oleg.
Our apologies.
Start with the demo of creating a cluster in different clouds, etc. Then Uma will talk about chaos engineering in general and about Litmus framework. And then we'll switch back to the demo and I'll show how it works with clusters provisioned by Kublr. So without further ado, let's start. Michaela did the round of introductions already. So I'm Oleg Chunihin, CTO and co-founder at Kublr. So a couple of words about Kublr and centralized Kubernetes management in general. So Kublr started as a vision when we at a custom software development company called Bank Technologies started to standardize on a set of technologies for application delivery and very quickly focused on Docker and Kubernetes, built a set of solutions and quickly realized that what we built is essentially a Kubernetes management platform that works on multiple clouds and that solves specific problems that larger enterprises have when they look at implementing cloud-native technology stack. And don't get mistaken, so those are real challenges because when you look at cloud-native technology stack at Kubernetes, at the first sight, it all looks very nice, very enabling, and provides a lot of benefits to developers, allows you to improve agility of your delivery and shorten delivery time. But then when you start implementing cloud-native technologies at scale, a number of questions arise. So how do you manage those Kubernetes clusters? How do you provision them? How do you provision them, especially when you're looking at different clouds and different environments? How do you meet requirements of developers on one side and operations teams, SecOps, IT ops, infrastructure ops on the other side? How do you bring together, for example, the need for self-service for deploying Kubernetes clusters by development teams, for testing, for prototyping, and governance requirements and strong security requirements, centralization requirements by IT ops teams and SecOps teams. So, and this is all the questions that Kublr aims to solve. So Kublr focuses on infrastructure management and Kubernetes management, providing centralized user interface, API, for cluster management, log collection, monitoring, identity management, and audit. So essentially everything that you need to provide a Kubernetes as a service inside of your organization while still owning the platform. So it's not a Kubernetes as a service per se. So you install this product in your environment and then use it to enable Kubernetes management in any clouds and data centers. So that's what we are going to talk about today as a first part of this webinar. So how do you enable centralized Kubernetes management in your organization, and about essential parts of such a Kubernetes management platform. So, and of course, the first part is centralized UI, observability, API, and infrastructure management, and that's what Kublr provides as a platform. So let me start and show how it may look like. So essentially, you install this centralized management platform either in your cloud account or in your data centers, and then you use it to provide different spaces. Each space can hold multiple clusters to different teams. So in this case, for example, I have a space called demo where we have 5 clusters deployed in different environments. But for the purposes of this presentation, I'm going to switch to another space where I will provision a cluster for our Litmus demo. So let's call this cluster Litmus demo. I'll use my Kublr workshop AWS account to deploy this cluster there. Let's use 1.18.9 Kubernetes, one master cluster. I don't need it to be too highly available with a T2 large instance. Let me enable SSH into that instance. We don't need auto-scaling. 2x large instances for worker nodes will be enough. And just in case, let's enable ingress controller in that cluster if we want to process ingress traffic later. Now our cluster configuration is more or less complete. I could, of course, further customize it. So, for example, if I wanted to deploy it on spot instances with mixed instance policies, or set up EFS as a persistent storage, I could do that through custom cluster specification. But we are doing a simpler demo today, so let's just start creating this cluster. It'll take about maybe 10 minutes, which will give us time to complete our presentation and talk about Litmus as well. So while this cluster is being created, let me switch back to the presentation and talk about other essential components of such a centralized Kubernetes management platform. So of course, cluster provisioning and cluster architecture is very important part. So in our case, in case of Kublr, for example, Kublr provisions Kubernetes from scratch, so to say, in all of the environments. So it actually provisions infrastructure and then deploys Kubernetes components on top of that infrastructure using uniform architecture across different clouds, which provides sort of this uniformity, even if you are running different clouds in data centers, in different clusters in data centers, in different clouds, etc. Although you can also register pre-existing or externally managed provisioned clusters like GKE, AKS, etc. We already saw this multi-tenancy where with multiple spaces that can be given to different teams with different permission rights. So it helps to organize infrastructure management. For example, you may have a production space where operations team only can manage clusters and make changes, but then there may be a dev space where developers have full self-service permissions. It's very important that those clusters are portable, and we will see today that, so you see that I have just created a cluster in AWS, but I already am running another cluster in Azure. And first of all, this cluster is there just in case if anything goes wrong with this one. It already runs the Litmus installation, and working with these two clusters is absolutely same, absolutely identical for end users. So infrastructure is different under them, but Kubernetes, this great common denominator, gives you this infrastructure abstraction that makes it possible to move your applications between clouds very easily. It's important that those clusters are reliably set up, so they use all the clouds recovery features, auto-scaling groups, etc., etc. So it's very important that the architecture of those clusters is solid and reliable and uniform, but there are some components to a Kubernetes management platform that are also very important for enterprises and need to be available from the moment zero. And those include things like centralized log collection, monitoring, audit, and identity management, in addition to multi-tenancy. So, and these are also part of Kubernetes platform with components like Keycloak identity broker, for example. So as a part of this platform, in the system cluster where the platform itself runs, we are running Keycloak identity broker, which usually, normally, out of the box is used to manage users in Kublr and in the clusters managed by Kublr. But it can also be integrated with Active Directory, LDAP, identity providers, or any SAML or OIDC based compatible identity providers like Azure Federation Services or Google Apps IAM or AWS IAM. And centralized monitoring and log collection are also very important parts of the platform. So collecting logs, all logs from all the clusters under your management and your all applications under your management into a single database allows you to create, well, common dashboards for applications that span different environments, for example, or analyze events, again, spanning environments and clouds. So you can analyze it by space, by cluster, etc., etc. So, and the same is true for log collection. So here, for example, we can see metrics collection. So here we can see, for example, metrics from different clusters under our management. So we need to refresh our Grafana so we can switch between spaces, see clusters, whether they are bare metal clusters or Azure clusters or any other type of cluster. So we'll work with our space called transient, where we have one cluster already and setting up another cluster. And as a part of the Litmus demo, we'll also show how applications and frameworks like Litmus or test application we'll use in the demo can be integrated with this metrics collection system very easily. So I want to talk in a lot of details about how these centralized systems are implemented. They are implemented using standard open source tools connected in maybe non-regular way a little bit, making sure that we can assemble essentially metrics and logs from all the clusters in one database. And we'll publish this presentation so you'll have a chance to review them and ask questions if you have any about architecture of these systems online. So other considerations that are important for a centralized platform may include backup and disaster recovery, Docker image management, for example, image scanning, etc., which can easily be implemented using open source tools or commercial tools available on the market as soon as you have this reliable Kubernetes platform that can run on any environment. For example, as one of our recent webinars, we talked about deploying CI/CD pipeline for on Kubernetes clusters, and so it's very easy to do in under 30 minutes to deploy fully formalized as infrastructure as a code stack with Jenkins, Nexus, and running on any cloud, etc., using again Kublr as a driver, as a tool for specifying your clusters and infrastructure. And the same is true for Litmus as a tool running on top of Kubernetes clusters managed by Kublr. So you can check Litmus GitHub account, where there are a lot of examples and a lot of documentations talking about how Litmus works, and I'll pass the word to Uma in a minute or so he can talk in more details about Litmus and what chaos engineering is. But before that, so just summarizing, so if you go to Litmus GitHub account, you'll see a lot of documentation talking about how Litmus can be deployed into Kubernetes cluster, for example. It can be used to manage, to test applications running in Kubernetes cluster. And one of the sections there about integrating with monitoring platforms include Kublr-specific documentation. So this is the demo we'll go through and show how easy it is. Most importantly, so using Kubernetes as a platform gives you this reliable infrastructure abstraction level that enables you using any tools of your choice for your developers or DevOps needs on any environment, on any infrastructure, and prepares you for future changes. Okay, so having said that, Uma, please, you can take screen and talk about chaos engineering.
Thank you, Oleg. Hi, everyone. Happy to be here on this webinar. About me, I'm Uma Mukara, co-founder, COO at MayaData. I am a co-creator of two open source projects, which are both in Cincia right now. Those are OpenEBS and Litmus. I primarily work in the areas of cloud-native data management or cloud-native chaos engineering. At MayaData, apart from managing the operations, I also manage the SaaS operations of Kublr. They also work very closely with SREs within MayaData as well as the community at Litmus. So today, in this next few minutes, I'm going to talk about briefly what is Litmus and how you can use it to increase the resilience of an application around Kubernetes. So Litmus, our mission statement is to help developers and SREs to find weaknesses and tune their systems by the practice of chaos engineering. It is a CNCF sandbox project. And apart from MayaData, there are a few other maintainers that are contributing at the moment. Intuit and Amazon are some of them. One of the assets of this project is Chaos Hub, which I'll explain in a few minutes. Chaos Hub is a place where we are hosting all chaos experiments together, and you can use them and upstream new experiments if you would like to. After becoming a CNCF sandbox project, the project is being adopted at a very good rate. We almost have seen 200% increase in the experiment runs in the last 4 months. And there are a lot of new contributions coming as well. So before I go to cloud native chaos engineering, or what is that cloud native chaos engineering, let me give a refresher on chaos engineering itself. Chaos engineering is needed to check as well as to tune the resilience of distributed systems, which in general is very complex because your production environment is always different than your testing environment, and it is continuously changing. So how do you do that? Is by following chaos engineering. And what is chaos engineering? You identify a steady state of either a component or a system, and you introduce chaos or fault and observe, because this is a willful introduction of a fault, you are ready to observe and tune the system and try to bring it back to the steady state. So it's also known as breaking things on purpose. Why we do chaos engineering is whenever there is a fault, and if it is totally unplanned, it could cause major financial implications. Instead, you plan the faults and improve the system by tuning them, and then bring back to a steady state, so that the unexpected faults, even when they happen, your service continues to grow. While if this is chaos engineering, what is chaos engineering for Kubernetes, or why? The good thing about Kubernetes is a lot of services around it are available naturally under the guidance of CNCF. The landscape has grown significantly in the recent years. And because of that, you will see a lot of services that your application need are already available, and they are changing very fast. So if your application is at the top, you will see that the resiliency of your application really depends on a host of other services. In fact, 90% or more than 90% of the resilience of your application depends on some other app or service or infrastructure. So how do you actually keep up the service resilience of your application? So it's by practicing chaos engineering. You have to continuously validate as each and every other component go through an upgrade or a change. You keep continuously practicing chaos engineering through your stack, and then make sure that resilience is not reduced or it is intact. So how do you do that? If this is what is a regular chaos engineering is, it's an introduction of fault, you wait for the fault to happen, and or you introduce the fault, and then you wait for your system to regain to steady state. If it is yes, the system is good. If it is not, then you have an issue. You have to find that issue. You have to correct the system by tuning some configuration or a variable, and then bring it back to the steady state and fix that weakness. So in the chaos engineering world of Kubernetes, you do that by automating the chaos lifecycle. So how do you do that? Is by using chaos operators. So you will have chaos experiments to introduce the faults, and you will have to have systems in place to check whether the steady state is regained or not, and then if not, to alert someone. So we do this in chaos engineering for Kubernetes world by three things. One is chaos operator. So Litmus has a chaos operator. And the second thing is set of CRDs. You have a Litmus engine, a chaos engine CR, and chaos experiment CR, and a chaos result CR. These custom resources will store the status of an experiment and the resource, and chaos operator works through them. The third one is the experiments themselves, which we keep them in Chaos Hub. I'll talk about that in a few minutes. So using these resources, you can practice chaos engineering, and Litmus enables you to do that very, very quickly in a seamless way in a Kubernetes native way. How do you scale this? Well, you know that you have got a good set of chaos experiments, and you can run them very quickly, but how do you scale them? How do you reproduce a complex chaos scenarios and you automate them? So for that, we have introduced chaos workflows. A chaos workflow is really based on Argo workflow, which is another CNCF project. Through this workflow, what we can do is we put together a sequence of litmus experiments, chaos experiments. We take them from the hub, you put them together, and you run them. So you create a chaos scenario through a litmus workflow. And once you execute those experiments, litmus workflow logic or the operator will consolidate the results by looking at whether the steady state has been regained or not, whether there is anything to be alerted, etc. So the consolidation of results is an important fact. It also tells whether your service level objectives have been breached or not, or if they're intact. So because this entire thing is done in through YAML syntax, it can be scaled up through automation using GitOps. So you can practice chaos engineering in an automated way, in a scaled way using GitOps and Litmus declarative YAML files. So that's the beauty of it. So you get basic fundamental units to introduce experiments. You get the entire lifecycle management through chaos operator, and you can create complex scenarios using workflows. You use that workflow and use them in GitOps manner and automate them. So with this, you can actually practice a production grade chaos engineering using Litmus. So a brief way of explaining Litmus architecture is when you take Litmus Helm chart, install, you get Litmus portal, and you can then take a predefined chaos workflow and then you execute it. The experiments get run, and chaos metrics and events and results are uploaded into portal as well as to your Prometheus. So you can then do the same thing on various other cluster. So Litmus supports executing chaos on different clusters. You don't need to install Litmus portal on every cluster where you want to practice chaos engineering. It is generally one Litmus portal per enterprise. And you can continue to do that. You have centralized monitoring of chaos results, centralized chaos interleaved analytics are available. And that's how Litmus works. So this is the Chaos Hub. As I said, it's been a great journey for the concept of Chaos Hub itself, where we are seeing a new experiments being contributed from different contributors. There are now 37 experiments, and how Chaos Hub works is you will most likely get most of the experiments that you would need from the hub, and around 70 to 80% of your chaos engineering needs are already available. And for your custom application, you can go and tune the existing experiments or add new experiments. And if your experiment is useful for your own users, when they use it in their environment, you can actually upstream it back to the hub so that they can practice chaos engineering for your application in their environment. So that's the idea of Chaos Hub. So what are the experiments of Litmus Chaos? We categorize them into two. One is generic, which is about chaos experiments for Kubernetes resources. We provide chaos experiments for CPU, memory, at a pod level, node level, and then network disk, and even a Kubernetes service, and at a Docker service level as well. So as you can see that there are about 22 generic experiments as of today, And these should be good enough for you to introduce any kind of chaos that you would want. And you have any more specific application experiments that you need. Some of them are available already and some more are in the flight. And using these experiments, you can create a complex real life chaos scenario. So another aspect of Litmus chaos is if you have a chaos logic that needs to be introduced and it is not available on the chaos hub, it's pretty easy to build. And we call that as bring your own chaos. So Litmus provides a good and easy to use SDK using which you can create an experiment skeleton. And what you need to do then is you put your chaos logic into a container image, a Docker image, and point that into the skeleton, and your experiment is ready to go. Then you can use that experiment into chaos workflow, and then you actually use the new chaos workflow. It's pretty easy to do. So in summary, how do you get started with Litmus is you start with a Helm chart, you get portal, and then you get to choose a predefined chaos workflow if you want, and you take that, you tune it, and you run your chaos. So a complex chaos scenario can be put into action within a few minutes if you know how to use Litmus chaos. So let me show some example screenshots of Litmus. So this is the portal screen. It supports team management as well. So you multiple members of your team can use this portal together, including the RBACs. And it also has all the chaos workflow and monitoring capabilities. So when you log in into the portal, you will see some various workflow that are in action. You can start creating a new workflow. And in the new workflow, you can choose a predefined one or create a new workflow itself. You can design a workflow. So in this case, you can pick a well-defined predefined workflow. And after you pick it up, you tune it. YAML file is available for your complete tuning. And then you can also adjust the weights of various tests within that. Because for each a user, a failure of a given chaos experiment mean different things. So we give an option to adjust the weights of that workflow, and then you can go ahead and then run it. So when the chaos workflow runs, you can schedule it at different times. You will be able to see through Litmus portal how exactly each experiment ran and what are the logs inside. And when it was executed, we can go much in detail with Litmus portal. So that's a good and quick brief summary of Litmus. And I would like to conclude this introduction session by summarizing Litmus as a complete framework for finding weaknesses in Kubernetes. For developers and SREs, it's a great tool to practice chaos engineering in a Kubernetes native way or cloud native way. So with that, I will give the session back to Oleg, where he'll be doing an intro of Litmus demo, where a fault is injected, and you will see the result of the fault in actual analytics on the Kublr monitoring platform. Thank you. Back to you, Oleg.
Thank you, Uma. And let's see it in action. So let's see how our cluster is there. Yes, and our cluster is cluster Litmus demo on AWS was actually created. So we can see everything is green there. Every component of this cluster is there. We can see a history of changes. So we can quickly check that it took about 10 minutes to create this cluster. And I already set a kubeconfig file for that cluster that you can also download from Kublr UI in my console. So we can run kubectl commands in my console. So what I'm going to do, I'm just going to go through this Litmus demo showing how to, so first deploying a test application, which is called SockShop. So let's see, the application is deployed. We can check it in the cluster dashboard. Let's see, here is the namespace for SockShop, which has just been created. And we can see that it's being started. Pods are starting. It will take maybe a couple of minutes. And while it's starting, we'll just go through the rest of setup. First thing first, we need to deploy a Litmus operator into this cluster to make sure that we can run the experiments. We will, there are several modes of deployment, so you can deploy a Litmus operator in the mode that it can do anything in any namespace in that cluster, or you can limit it to a certain namespace. So that's what we are doing right now. So I applied a set of airbag rules that allow this operator to work within that cluster. And now I am deploying a set of predefined experiments from the Chaos Hub, just exactly as Uma described. Now let's see how our test application is. So let's check what's the pod status, and most of the pods are running. We can see this application in Kublr monitoring. So here's our Grafana, and we can see our transient space in which we have two clusters. And this new cluster called Cluster Litmus Demo has just been started, as you can see, maybe 20 minutes ago. And in this cluster, we have just deployed the application. Here is this new space for SockShop. So we can see CPU usage, for example, for the pods that has just been started by us. So there is no dashboard for Litmus testing yet in this monitoring, and we'll fix that in a second. Kublr provides a number of standards pre-configured dashboard for CPU usage, memory usage, disks, etc. out of the box. But you can also, of course, customize those dashboards or add your own application specific. And that's exactly what we will do within this demo, deploying different components and enabling Kublr monitoring system to collect metrics from them. So right now, what I'm going to do is to deploy Litmus Chaos monitoring component. So those components essentially exports metrics in Prometheus compatible format. And one last step that we need to do is we need to annotate certain services in our test application and in those Litmus exporters so that Prometheus created by Kublr monitoring can know that those custom metrics need to be collected. So, and again, so this is literally just annotations. So we just mark some of the services deployed in that application with a Prometheus IO scrape equals true annotation. And that's all we need to do to integrate pretty much any metrics exposing application with Prometheus in general and with Kublr monitoring subsystem in particular. So you see, I annotated services in Litmus namespace, and I annotated services in the custom application namespace. And now we are ready to import custom dashboard, Grafana dashboards that will visualize in much better and convenient form what is happening with chaos testing in this cluster. And again, it's very easy to do with Grafana provided as a part of Kublr monitoring subsystem. So we import SockShop performance custom dashboard into Litmus directory using standard Prometheus data source. And we will import, and you see there is already data here. I'll talk about that, why it's there in a second. I want to import another dashboard which looks at pod metrics first. Here it is, and importing Prometheus. Okay, so we have now two new dashboards in our monitoring system. Let's go to the dashboard called SockShop Performance. We see there already certain tests run and chaos experiments running. Why is that? It's because we are seeing them in from this DEMA OLM OPA cluster, which I already had in my space before. Remember, I mentioned that we have this cluster just in case anything goes wrong with the new one. So I already had Litmus deployed there, and experiments are still running there, and metrics are collecting, and we can see them in this dashboard. I can easily switch. I cannot switch to another cluster because there are no metrics collected yet in that other cluster. So we will need to first run some experiments and see if we can collect some statistics from the application, from the custom application deployed in the new cluster. Let me reset everything here, and I'll create a new experiment object called, as you can see, catalog pod CPU hog. And we can check status of this object just running kubectl describe command. So we can see that Litmus is at work. So it's chaos operator noticed the new experiment, validated the resources for that experiment, and is actually creating a job to run that experiment, updating. Okay, now we see that this experiment is actually running. So we will need to wait for a minute to see how it goes. Meanwhile, we can check if the metrics have propagated. Yes, here it is. Now we have metrics from our new cluster, and we see custom metrics collected from different components of our test application. There is an order microservice, there is a catalog microservice, payments microservice, shipping microservice, user microservice, and a number of others, card, front end. So this dashboard is specially designed to collect custom metrics from all these microservices, so it's specific to this application. But as you can see, it also uses the fact that Kublr collects metrics from all different clusters, and it distinguishes between metrics collected from different clusters. So if we check queries sent by this dashboard to Prometheus, we will see that they include Kublr space and Kublr cluster names in the query. It's those parameters that we select here so that we can switch between different clusters. So, and this dashboard also shows an example of annotating graphs and charts with experiments. So if we check the dashboard definition, we will see that there are 4 annotations, so-called annotations. that also include certain Prometheus queries. Those annotations essentially put these yellow marks on every chart in this dashboard when some experiment is running. And as you can see, we have started this pod CPU hog experiment. It's still running. It runs for about a minute. And the dashboard sees it by running annotation queries and puts these annotation marks showing to you where is this place where experiment is actually running, so that you can see how it affects, for example, certain microservice performance. So, and we don't have much statistics collected here yet, so it's not very easy to see how those experiments affect affect performance here, but we can switch to the cluster where we do have that statistic collected, and we may be able to see some correlations with different experiments. So there are actually 2 or 3 experiments scheduled in that cluster to run regularly, and we can map where those experiments run and how they affect performance of this or that microservice. So let's see our cluster. So, and in this cluster, our experiments, I suppose, coming to completion. Yes, so it's been passed. So in a second or 2, we will see that here the annotation will end and stop marking the running experiment. So we can follow the DEMA and run other experiments. Like, for example, this was a CPU hog experiment for catalog microservice. Another experiment here is a memory hog for orders microservice. Let me run it. And why I want to run it is because you probably noticed that catalog microservice memory hog doesn't really affect catalog performance very much. Looks like this microservice was designed well, but what I know from experience is that the orders pod memory hog experiment does really affect performance of some of the microservices, and we may be able to see it in the charts in half a minute, hopefully. Meanwhile, the data for that experiment is collecting. We can also talk about automating those experiments, and one great way to automate and visualize those experiments that Uma talked about is running Litmus portal. So, and you can check on Litmus GitHub account. There is a directory in the Litmus project called Litmus portal. It has instructions on how Litmus portal can be deployed. It's just another kubectl apply command. But we'll use a different method also explained in the Litmus project, namely using Arga CD tool to run various workflow and automation tasks. So let's say, so first of all, we need to deploy Arga itself, which is again very easy. It's just a couple of commands. Arga CD uses its own command line, so it explains here how Arga command line can be installed. So we will need to deploy Arga access service account. I already have Arga command line installed, so I skipped one step. And now we can actually run a Arga workflow. So I'll need to point to use my command line tool, which is not properly installed. It's just staying in the same directory, few levels above. So, but I will use cron create task there for a catalog not CPU hog workflow. And now we can also visualize Arga workflows using kubectl port forwarding or opening this Arga portal UI as a node port or load balancer, or using that ingress controller that we deployed as a part of our cluster deployment. There are a number of ways, so you can just open endpoints to your applications running in the cluster using any means available for standard Kubernetes clusters. Now let's see what happens in our cluster. Now we can see, by the way, that it looks like the other experiment showed us that orders memory hog does affect performance. So we get higher orders latency when we run orders memory hog experiment. And this is a good input for developers who can now try to figure out how to maybe make that microservice more memory efficient. Okay, so this covers our quick demo. Please check our corresponding websites, Kublr and Litmus. And I think now we are ready for questions.
Hello, everyone. So we do have a few questions. The first one being, what value does Kublr provide for Litmus user if it just deploys a standard Kubernetes cluster?
Yeah, so good question. Thank you for that. So, well, one, of course, it's that it's a standard Kubernetes cluster, multiple standard Kubernetes clusters across different environments. So you don't need to think about how you would do that in Azure or in AWS or on-prem. So this all is supported by Kublr, and essentially that demo would look exactly the same if I did that on-prem or in any cloud supported by Google, by Kublr, Google Cloud, Azure, AWS. Another reason and value Kublr provides is all these operational tools that are already available, including centralized monitoring and log collection. So you saw in this demo how you can integrate any metrics exposing application, and that's very easy, just one annotation away. So you don't need to think about how to set up and maintain Prometheus, etc., etc. You already have it in place and ready to be used. Portability and operational tools out of the box.
Okay, and how does Kublr protect credentials to AWS, GCP, and so on?
Was it how Kublr protects credentials for AWS? Yeah.
Yes, and GCP and so on.
In a similar way to Kubernetes secrets. So to create a Kubernetes cluster in Kublr, you need to first create an object called credentials. It's similar to an object called secret in Kubernetes API. And those credentials, that object contains your access key, secret key, or other credentials necessary to access the cloud account. And that object is stored in Kublr database, but again, similar to Kubernetes secrets, there are special precautions on storing secret information. So it's encrypted. It can be encrypted at rest, and it's encrypted in transit. So hopefully this answers the question.
And do you have any chaos experiments for infrastructure?
I can take that question. Yes, we do. Litmus provides a couple of types of experiments if you want to classify them as. One is generic, the other one is application specific. So in the generic category, you will have experiments that are related to Kubernetes resources such as pods and services and containers. And the other category is infrastructure, right? So this falls into Kubernetes nodes and Kubernetes disk and physical networking. If you go to the Chaos Hub, you will see there is an yellow tag on each experiment that indicates that it has higher blast radius because it's going to introduce chaos into infrastructure. And also, if you are after a specific infrastructure resource, you can define your own chaos experiment as well, right? And using Litmus, it's very easy to create new experiments. You have an SDK, you spin up a new experiment, you get all the skeleton, and put your chaos experiment into a Docker image, and then there you go. You got a Litmus experiment. Yeah, it's there.
And then we have one more question, just a little bit more time for one question. Uma, in about 1 or 2 minutes, do you mind letting us know how we can run Litmus Chaos experiments within a namespace?
Mm-hmm. Yes, within a namespace, basically Litmus, you can run it in an administrative mode or within a namespace. So nowadays, it's very common to see a Kubernetes cluster is being shared across multiple developers. You might not own a Kubernetes cluster all the time. So all you have access to is a set of namespaces or one namespace. So you own the resources within that namespace and you want to introduce chaos into that. And you can run the entire Litmus operator and Litmus experiments within that namespace by following the namespace mode of Litmus. And all you would need is your administrator should have installed the set of chaos CRDs, the custom resource definitions. And once you have them, you got everything that you need to run chaos within namespace. So if you have, it's possible to have multiple instances of Litmus within a Kubernetes cluster, and that's how it's easily scalable as well.
Great. Well, thank you all for joining today's webinar. Please feel free to reach out with any questions or topic suggestions at the email provided. And we do hope that you can join us next time. Thank you, Uma, and thank you, Oleg.
Thank you.
Bye, everyone.
Bye.